Hi, today's lecture is about an introduction to artificial intelligence and learning. So I'm Priyal Valpiter. So you can reach me uh, via any of these social media. If you have any questions or anything to clarify, you can reach me through this. And so I'll do a little introduction about myself. So I'm the CTO of Sorosine. It's a USA-based company. And apart from that, I'm doing visiting lecturing at University of Columbus School of Computing. And yeah, so this is about brief. So let's go into the lesson. So the lesson is about, as I told you, artificial intelligence and machine learning. So if you are with the technological stack these days, you know that this AI and ML is kind of like a buzzword these days. It's a trend in technology. So first of all, we need to identify or understand why it is become very popular and become mainstream tech technology recently. Uh, so before going into deep AI and MA, so let's describe why it is important. So I have taken this idea from this nice book called The Fourth Age by Byron Reese. So according to him, the mankind had leaped through mainly four stages of evolvements, which are very essential. So the first is, as humans, we harness the fire that was around 100,000 years ago. So why this harness of fire is important for us? You know, before we have harnessed the fire, we used to like take raw and the amount of nutrition that can be absorbed from raw food is very low compared to cooked food. So what happened was that because of the invention of this fire, people used to consume their food uh, after cooking. So that enabled to consume more energy or more nutrition into the body. So I don't know whether you guys know that 20% of the energy that we are consuming from our food goes to our brain. So that's why human is considered as the animal which is high, which has high intellectual power compared to other animals. So that cooked food, it triggered a lot of brain power back in 100,000 years ago. So I think the second age or the second great leap, we have people have developed the agriculture, which led into construction of cities and warfare. So why this one is important? Because for the first time in history, people gathered in one place and try to do their tasks, their day-to-day tasks, their social tasks as a one community, as an individual or as an individual family. So that helped to build a lot of things as a community, not as an individual. So according to Byron Reese, the third age is around 5,000 years ago when people invented the wheel and writing. So why this one is important? So if you're talking about writing, so far up until the third age, if there's a knowledge being gained or being developed in one community or one society, that that particular knowledge or technology born in there and died with the community. And after like uh, 3-4 generations, so that knowledge also get decayed. So what writing enables is to write down whatever the knowledge that they have gained so far. So people used to write earlier in the papyrus papers and all. So they can write the technology advancements and everything that they have written uh, or they have invented so far. So the next generation can start from that point onwards. So they don't want to go into the square one back again. and it can be transferred into other societies as well in the same country or in other countries. So that's how, so that is why this writing is a great leap of a human evolvement as the third stage. So what is the fourth stage? So you may have like different answers for fourth stage. When I doing this lecture in a classroom, a lot of people saying that it's the steam engine, or the combustion engine, invention of electricity. But the fourth age, according to the binaries, the fourth great leap of mankind is artificial intelligence. So why? Because for the first time in history, we managed to transfer our knowledge into a machine. So it means that we can take decisions without using human brain. So you might ask the question that whether are we in that situation yet? To answer your question, we are not there yet, but we are leading into that. So you can, that there are a lot of tools that we are using in work without using our brain power. So that is why this artificial intelligence is very, very important, because according to binaries, that resembles the fourth age of human evolution. So let's examine what are the subsections or sections of AI and ML. So you can see AI and ML can dissected into a Venn diagram like this. So most generic layer, we have the general AI, and down that we have the narrow AI and machine learning and the deep learning. So what do you mean by the general AI? And the question is that whether we have achieved the general AI yet. So general AI means if there's an AI system that can do any generic task, not a specific task. So what kind of system is that? Let's say one example that you build a robot and that can do singing, that can drive a vehicle, that can do cooking, like that. So based on that definition, we haven't achieved the general AI concept yet. So what we have so far is the narrow AI. So narrow AI is the concept or the general machine learning that we are dealing today. So what are systems that we are having as an example? So AI, it's there, it's out there right now. So even you are using this AI day to day. So I mean, if you take an example, the Google search, most of you guys are doing Google search day to day. So earlier, I mean, it used to take these indexing algorithms and all, but it's mainly powered by AI nowadays. And if you are using Facebook, all the advertisements and everything popped out to you using AI technologies, like the recommendation systems and all. And if you're going into Netflix, the Netflix shows you the movies that you like. So that is also the technology behind that is also using the AI, because it knows what kind of movies that you have watched earlier. So based on that, they are using AI-based recommender systems to show you that movies that you would like as well in future. So what do you mean by narrow AI? So narrow AI is an AI system which is designed to do one specific task. I mean, let's say one example, if you take the Tesla's auto driving or autonomous driving AI system, that is only designed to drive the vehicle. I mean, it cannot do any other task. It cannot, sing a song, or it cannot recommend you some video from a video stream. So that is specifically designed into that. So almost all the AI systems that we are having right now, as of today, are narrow AIs. Machine learning is a subset of narrow AI as well. So mainly we are going to learn the machine learning in this lesson. So deep learning is also a subset of a machine learning. So I will explain you what are the differences in between the general machine learning and the deep learning when we continue further. Okay, so a little bit of history in AI. So you guys think that this AI become a buzzword very recently, but this is not a new technology, or artificial intelligence or machine learning is a new technology, and it's been there from the beginning of the computers. You can see the early models were developed in between 1940 and 1960s. So because in the early scientists, they believe that, okay, they have invented the computer, so it's a machine, and they can embed some kind of an intelligence from the beginning. So based on that, the first artificial neural network, so I'll explain you what is the artificial neural network in a while. So the first neural network is a one neuron being developed by Frank Rosenberg in 1948. So that neuron is called the perceptron. And after that, there are some early models as well. Minsky and do something. And the backpropagation algorithm first initiated by the Ramalhart in but this AI, even though these things been built, it's not been become popular those days. So there's a one big reason behind that. So even as of today, the most of the machine learning models that we are using, it consumes a lot of power. So you have to have very powerful machines to train your artificial intelligence systems and use these things. So earlier, you know that we didn't had so much of powerful machines. So the concept was, but it become popular mainly because of the advancement of hardware. So now we have faster machines, so we can do this very easily. And the other reason is IoT and big data. You know that the machine learning that we are using today, in order to get them trained and all, you need to have a lot of data. So the concepts like IoT and big data emits a lot of data which is useful to train the machine learning model. So that is one other reason that the AI and ML technologies become popular these days. So this is a little bit of a history timeline. These technologies. You can see the Rosenberg is there. He developed the perceptron. So these are perceptrons. So I'll explain this thing further during the lecture. And so there's something called like AI winter as well. So this during this period, 1970 to early 1990, nothing been done in the fields of AI. So Jeff Hinton, considered as the father of AI, is mainly because that he was there in this AI business or in this field from like late 90s to as of today. Because earlier, scientists say that you cannot achieve what we are thinking as AI today. So that is mainly happened during this AI winter period. So, but Jeff Hinton was hanging to his ideas, and he worked mainly in the fields of neural networks. So, but later he would the glory on behalf of AI. So that's why that he is considered as the father of AI. So you can see the deep neural network, he contributed a lot, even late as 2010 as well. Okay, so this is kind of like, formal definition that I grabbed from Wikipedia. It's called the intelligence demonstrated by machines in contrast to neural intelligence displayed by human. So this is the formal definition. So, and there's another thing that I want to emphasize in here. There's a thing called Turing test. The Turing test has been proposed by Alan Turing in 1950s. So according to him, the Turing something like this. So if you engage with any system as a human, if you cannot tell exactly whether this system is driven by a classical programming or artificial intelligence, if a human cannot determine that, so it means that that particular system is Turing test pass or is Turing test capable. So if human cannot detect in between the difference in between normal classical programming and artificial intelligence driven programming. So that is the Turing test. So if we move ahead, so what is AI and ML? So these are two things. So machine learning by Arthur Samuel's definition is machine learning is a science of getting computers to act without being explicitly programmed. So you know that whenever that you are doing programming using Java, C Sharp, Python, whatever, that you have to instruct the machine to do anything. If you are doing addition, subtraction, or whatever the thing, you have to code it. And the program doesn't do anything more than that or less than that. It's what we have instructed, and the program supposed to execute that as it is. But AI system is not like that. It's like it's not a binary thing. It's not like do or don't. Because AI system, as humans, it can learn by itself, and you cannot predict what it would do. So there's this fuzziness is there in AI systems. So and the programs, they've been built in a way that there's a little bit of fuzziness. So we'll examine this thing later on.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting. Software is going to solve that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we've talked about on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
Wouldn't it be wonderful if someday we got to the point where there were robots every place, they were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart, that's way out in the future and probably worth talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which is relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite Autopilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic. We have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important thing humanity has ever worked on. Now, I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. Stepping back, when you think about a lot of problems in the world today, it's because we typically have a constraint on resources. AI, for the first time, I think, over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes of driving and be at least 100 to 200% safer than a person by the end of next year. We're talking maybe 18 months from now.
The idea that there's going to be a general AI overlord that subjugates us or kills us all, I think is not something to worry about. I think that is overhyped. First of all, we don't know, we're nowhere close to knowing how to build a general AI, something that could set its own objectives. But second of all, I think it's unlikely that such a thing's first instincts would be to exterminate us. So I'm optimistic about that one, and certainly don't think we need to worry about it today.
After that nice video about introduction or some thought leaders in AI, so let's examine the difference between AI and ML, or artificial intelligence and machine learning. So these two terms are coining each other among the community. So let's examine the main difference in between these two. Okay, I think most of you guys have watched these two movies. This is Terminator and this the Iron Man. So in the Terminator, is we are considering as a fully AI system because there's no human behind that to control this machine. So it can take its own decisions, and it is it can sustain by its own. So so that is an example of pure AI. So it is a self-independent system. But what is the machine learning? So machine learning, you can see, so this is the Stark suit or the Iron Man suit. So this Iron Man suit cannot operate by itself. So always the actor needs to go inside into the suit and operate it. So it can enhance the power of the man inside. I mean, let's say one example, the man itself or the human inside this machine or inside this suit cannot fly by itself. But once the human is inside in this machine, so it can fly. So like, or he can fly. So like that, the machine learning is always is something like human driven. So there should be a human intervention with the system in order to succeed machine learning. But artificial intelligence is nothing like that. It's a self-sustained intelligence system. Okay, so let's move into the next slide. So in here, by learning artificial intelligence and machine learning, anyone's objective is to become a data scientist. So that is the the industry, the term that we are using for the guys who are dealing with machine learning and artificial intelligence. So so in order to become a pure AI guy or a pure machine learning or data scientist, there should be like 4 disciplines that you should be expelled in, or you should master it. So this is not my diagram. So this diagram is defined by Stephen Kosala, and this is the diagram or the principles in AI that the community is identified as that you should be mastered with. So the first thing is the communication. So you have to be good in communication. I mean, that is irrespective of machine learning and AI. You have to be good in communication if you are studying anything. And other thing is statistics. I would say this is statistics is with mathematics. So you have to be very good in mathematics as well, because in order to build a good AI or ML model, there are a lot of mathematics involved in that, especially things like calculus, theory about vectors, the linear vectors, and linear regression, the regression, multivariate calculus, principal component analysis. So you have to be master these kind of mathematical concepts in order to master data science as well. And programming. Programming is, of course, you have to be there because all these models, you have to program them using things like Python or TensorFlow or Azure machine learning. So its programming is there. And the business. The business is also very important because you have to be very clear what you are trying to solve with these machine learning problems. If you have your data set and if you have your model, that is also fine. But if you do not know what you are going to solve with this data and your AI models, you are not going to succeed. If you have all these 4 disciplines mastered, then you can become a perfect data scientist. Let's see what are the types of machine learning now. So from here onwards, I'm coining the term machine learning instead of artificial intelligence, because now we are going to focus on this more concrete subject of machine learning. Mainly, there are 4 different types of machine learning, and apart from these 4, there are a few others as well. But in the industry, these are the main 4 machine learning types that we are using. So the first one is the supervised learning, and the second one is unsupervised learning. Third one is semi-supervised learning, and fourth one is the reinforcement learning. So in supervised learning is mainly categorized into 3 main sections, that is classification, regression, and deep learning. So deep learning is mainly do with artificial neural networks. So that is one of the main areas of machine learning as of compared to any other area. So let's go ahead and see meaning by the supervised learning. So in supervised, as you can see in this structure or in this diagram, we have mainly 3 sets of data. That is the training data, evaluation or testing data, and new data. So what you are doing is you are building your model, your artificial intelligence or machine learning model. So this one is called hypothesis. Using the training data, you should train your model, and after that you have to evaluate your model. So it means that the training, the model should give you some kind of an error. So I'll explain that thing in a while, what is that error is and how to do this thing. And based on that error, you are doing the evaluation. On this evaluation result, you are fine tuning the hypothesis and train again. So this cycle goes on like that. And after that, after you satisfy with the training phase or you are satisfying with the error rate, then you are moving into the accepted hypothesis. Accepted hypothesis means that your trained model or your trained ML model. So in here you are doing the evaluation data. So you have to keep in mind that you have to separate the training data and evaluation data, because you should not put any data which you have used in training to evaluation, because otherwise it will give you false data, because the system is already trained with that specific set of data. So evaluation data means testing data. So you are using this testing data against your accepted hypothesis or accepted ML model. So then it will give you the evaluation result. So if the evaluation results are not satisfactory, then you have to go back to the training phase and retrain your model. And if it is accepted, then you are deriving your finalized hypothesis or the finalized module. So this one is the final module that you are using in your production environment or in your real usage. So in there, you use the new data set, which not been seen in training or evaluation, and doing your real predictions or real output of your machine learning module. Okay, so now let's examine how you can do this supervised learning. So I'm going to give you some example. And let's say that there are some data set which you have 3 input types, which are X, Y, and Z. And you have the output data, let's say as alpha. So assume that this is some kind of stock market prediction data. So assume that this X, Y, and Z are some independent variables in your stock market, and alpha is as the final stock value that you want to predict. So what we have is we have our previous stock data. So this is we can consider our previous stock data as our training set. So what you can do is, let's say that we have 100 data records, 100 data records. So then we are splitting this thing for 80% of training and 20% for evaluation. And let's say that we have our first data set as this. Let's say X is 10, Y is 10, and Z is 8. So this could be anything. You can assume any stock value. And let's say that closing stock pricing for this, if you input this thing, it should be 20. So this is just an example, right? So let's say in the second set, we have X as 11, Y as 12, Z as let's say 8 then again, and this one should be 22. So this is the actual value from our data set. And in the third one, let's say this one is 8, 7, 10, this one should be 18. Okay. Now what we are doing in supervised learning is let's say that we are inputting this C, X, Y, and Z as our first data set. So in the first phase, this supervised our ML model is so dumb, so it doesn't know any relationship in between this input and this output. So it would predict any arbitrary value. Let's say, for an example, it just predict this value as 1000, the output. So you can see that there is this error. So error is, in this case, is 980. So this is the error. So then we have to tell back our supervised learning. In supervised learning, we have to tell back into our system or ML model. Okay, you guys have input 10, 10, and 8. So we got the error as 980. So the ML model should tune itself to correct it more. So in the second phase, let's say that you enter 11, 12, and 8, and now it is outputting, let's say, as 500. So you can see that error has gone down. Instead of 22, it's output 500. So error in this case is 478. So you can see now it has dropped down. So likewise, our objective should be minimize this error. So this is the fundamental of supervised learning. So what you can do is you can define some threshold value. Okay, after, let's say, if the error is less than 2, we are stopping our training and we are going to evaluate our system. Okay, so let's examine what are the types of supervised learning. So the first type that I'm going to show you is the linear regression. So in linear regression, is mainly used to predict time series analysis. So that means any data set against the time. So as depicted in the definition, it is using to predict a continuous value based on observations features. So that means, first of all, assume that we have some scattered data set like this. So we need to build our model in a way that to find out an equation which can represent our data set best. So this particular equation, which depicted in the blue line here, represent the best data representation for this data set. So what you can do is you can see that our training data set is ending in the value of 20. So what we can do is we can extend this curve and predict any future value as well. So that is the linear regression is one type of supervised learning. And the other type is the contour regression. Contour regression is also a subtype of linear regression, and mainly it is using the Bayesian regressions. So instead of predicting only one value, it's predicting 3 different contours. Quantiles means 1/4 of each prediction. So at the end of the prediction, we can get the best suitable prediction out of these three. So this is the quantile regression. So in the linear regression, I told you in my example that we have to calculate the error. So in linear regression, this error is representing as the cost function. So cost function is, so there are different ways of defining cost function. This is one way that I have represented here. So xi, the difference between the xi and the yi is the error that we are having. So we squared it and sum it together and derived by 2 times of the number of items that we are having. So that is the example of cost function. So the objective is in our linear regression or in our supervised learning model to minimize the cost function. That means minimize the error. So you can see that this is the convergent function that we are using. So I'm going to explain deep mathematics in here. So by each iteration, so you can repeat until convergence. So repeat until convergence means that we define some threshold earlier on. So until we threshold, we apply our data set one after another into our machine learning model during the training phase. So that is how we are training the model. Algorithm is called the gradient descent algorithm. So there are some more efficient ways of calculating the gradient descent algorithm. So this one is using calculus. So instead of using, repeating one after another, we can use calculus to define the minimum cost function using this method. You can see there's one variable in here that's called the learning rate. Learning rate means how far you want to train your system. So this is the graphical representation of gradient descent. So if you have get mind blow if your mind got blown off with the equations in previous 2 slides, so forget about that. So you can focus on these things. So I'll explain. But the simplest form of gradient descent. So what you can do is, so this is our first error or the first where that we are starting. And I told you that our objective is to minimize the cost function. So you can see that if we go in this way of curve, it minimizes the cost function. It is minimizing the cost. So this is the threshold that we have defined here. And one more thing that I want to mention here is that in machine learning, it is very hard to make the cost as 0 because there's always some kind of an error rate. And there are systems that you can make it as 0, but I would say 99% of the systems, when you are training any machine learning system, it is almost impossible to make the cost function 0. So we have to define some minimum here. So we need to do the training until our cost function reaches minimum. And we have to stop at certain time as well, because what it would do with the training, it will go up again. So we have to stop at the predefined minimum. And so this is 3D representation of the gradient descent. So you can see in our previous slide that we had only one dimension, but when we are dealing with a lot of machine learning data, we have a lot of dimensions. So this is an example of machine learning where we have 3 dimensions. So you can see whenever that we are having a 3 dimension, there might be a lot of gradient descent functions here. So you can see, so this one, but if you go in this path, if you descend your algorithm in this path, it's also descending, but you have to make sure that this one is not the most optimal minimum point in this curve. Actually, the most optimal minimum curve is in here. So whenever that you are training your model, you have to make sure that you are going in the most optimal path. So there are a lot of techniques that where you can use to get this done properly. So I'm not going to explain very detail in there. But imagine that there are like, n dimensions in there. So there could be like a lot of local minimas in lot of dimensions. Okay, so this is another type of supervised learning. So this one is called logistic regression. So in linear regression, we always predict that one value, but in logistic regression, we are not predicting a one value. We are predicting whether it's true or false, or based on two numbers. So it's only a binary. So that is why the logistic regression also named as classification, because we are classifying one example to another. I mean, a best example that I can give you is, assume that you are training a model to identify humans. You are trying to build a machine learning model where you can identify humans, and you are throwing a lot of pictures into your training model, and you tag out, okay, this picture has a human, this picture do not have a human. So in this example, it is either we have human or we don't have a human. So it's only two outputs that we. So in this kind of a system, for this kind of systems, we are consider them as logistic regressions. Okay, so now let's move into the unsupervised learning. So far we have talked about the supervised learning. Now we are moving into the unsupervised learning. Unsupervised learning, we do not have any training data set. Instead, we have only one data set, and we need to come up with some solution, a machine learning solution with only with that data set without doing any supervised training. So let's see how we can do it. So one technique for that is called k-means clustering. In k-means clustering, what we have is we have some scattered data set like this, and after performing the k-means clustering, so k-means clustering is some kind of a technique that we can use. Is then again it is a mathematical technique. I'm not going to explain that thing in here. So after some training, you get some classes or classifications like this, some segments. So this is one example of using unsupervised learning. So I'll give you some real world example into this aspect. Let's assume this x axis is the age, and y-axis is, let's say, as an example, your blood sugar level. So you can see that after doing this k-means clustering, you have three clusters here. So you can see if the age is high and these guys do not have blood sugar, so you can consider them as healthy aged people. And in this section, you have aged people who have high blood sugar level. So you can see, you can name this cluster as the aged diabetics people. And these guys are young and they do not have the high blood sugar in their blood as well. So you can cluster these guys as young healthy guys. So this is just an example of use of k-mean clustering under unsupervised learning. And the other area that we need to examine is component analysis. So principal component analysis is mainly a dimensionality reduction system, because whenever that you are trying to do any data analysis, you are getting this big data or a lot of data which has a lot of dimensions, let's say 30-60 dimensions. But whenever that you are trying to build a system for these high dimensional data specs, you need to that particular model consumes a lot of computing power because of high dimensionality, and it takes time to train and time to evaluate as well. So a lot of computing power, I mean, this is resource hungry, and it takes time as well. And so adding these two things together, it costs you a lot. So what principal component analysis is doing is, it is reducing these dimensions into fewer dimensions. So then again, this one is a a mathematical model. I'm not going to explain deep into that. For the time being, just keep in mind that the principal component analysis is a dimensionality reduction. So then you can reduce your data spec or your train into lower dimension and get it trained more efficiently. Okay, so now let's examine the reinforcement learning. So this is another type of machine learning. So in reinforcement learning, yeah, not like dealing with huge data sets and all, unlike in supervised learning or unsupervised learning. In here, what we are doing is we are doing some kind of a point system to train the machine learning model. So this reinforcement learning is mainly highly used in the places like game trainings and all, to train bots to play games against humans. So this is one way of doing it. So in here, you can see that we have the agent. So we can assume this one as a bot. And you have two systems here. One is fire and one is water. So this agent doesn't know anything about these two environments, whether this one is hazardous or whether this one is okay, doesn't know. So what it's doing is first is going into the hazardous place. So then we are giving it minus points. So then agent learns, okay, if the agent go near to this kind of a hazardous place, it will avoid minus points. So it is trying to avoid to go into this kind of places again. And if it is going into the other place, we are giving some plus points. So it is trying to always go into this kind of place. So this is reinforcement learning is one way that humans are learning as well. I mean, we are using supervised learning a lot, but reinforcement learning is also there. So assume that whenever that as a kid, if you are trying to ride a bicycle, so this is how we learn. So kid, first of all, I mean, you come, somebody else cannot teach how to ride a bicycle. So kid going into the bicycle and falling several times, and then he or she realized that if you do this thing, the bike will get fell down. And so that's the reinforcement learning. So there are places that you cannot use reinforcement learning as well. As an example, can you train an autonomous driving car using reinforcement learning? So that is impossible. Otherwise, car will get crashed everywhere, and it will hit people and all that, and you can't give points into that. So that is the reinforcement learning. So let's move into the artificial neural network. So that concludes the section of types of machine learning. Now we are moving into artificial neural network. So artificial neural network you can use as supervised learning, unsupervised learning, or reinforcement learning as well. This is like highly researched area in machine learning. So the most important thing is in artificial neural networks, it is mimicking the same functionality in our brain. So this one is a brain cell. On top of here, what we have is a brain cell. So we have the inputs into our brain cells as dendrites, and we have the output from one brain cell. It's called axon, and we have the nucleus and the cell body. So all our memories and everything resides in this nucleus. So what it's doing is it's getting input from these dendrites, and it process. It's using the cell body and the nucleus, and it is output some value into another dendrite of another neural network or brain network. So this one is also similar to that. So this is the perceptron that built by Rosenbal back in 1948. So it also has set of inputs and some set of processing unit and an output. So this one is have one-to-one resemblance in between our brain cell and the artificial perceptron as well. So that's why this thing is called as artificial neural networks. And so that is a one network. So in here, artificial neural network has millions of networks. I mean, these millions of neurons connected together. So I mean, these things are connected in a way that it has layers. So as the first layer, you have the input layer. So this is where that you are getting all the inputs, and at the final layer, you have the output layer. So this is where that you are outputting anything, and in between, whatever in between that are called as hidden layers. So in between that there are something called weights. So weights is resemblance the memory of this artificial neural network. So that means that you can assume that if we have more layers and more hidden neurons, that means we have more memory. So if you are trying to train very huge data set, which has a lot of complexity in it. So obviously you have to have very complex neural network with a lot of hidden layers and a lot of neurons in each layer as well. So these are the types of neural networks that we are having. So first one is the convolutional neural network. This one is used mainly in computer vision and sentiment analysis. And recurrent neural network. So this one is mainly using speech recognitions and natural language processing and text analysis. And there's a thing called sequence to sequence models. So this one is mainly using in machine translation and chatbots. This translation from one language to another. And we have multi-layer perceptrons as well, mainly for classification. Are the main 4 types of artificial neural networks. Then again, I'm not going to go deep into these artificial neural networks as well. It's a very deep area of study. And artificial neural networks also considered as deep learning as well, because of this structure, because that we have the deep hidden layers in here. So that's why the term or the coin deep learning come into neural networks. Okay, so let's examine what are the few recent applications of deep learning or artificial neural networks. So you might have heard there's a game called Go. So this is a traditional Chinese game, and unlike chess or checkers, this one is very complex game, and it has infinite number of moves that you can make. The number of moves that you can make in Go board game considered as the number of moves equal to number of atoms in the universe. So then you can examine how many moves that you can make. So back in 2016-17, Google built uh, an artificial neural network called DeepMind. So it's challenged the current Go champion back then into an open game. So a lot of people thought that this machine cannot beat this guy, because you need to have some human touch or human mentality to play this game called Go. But end of the day, the DeepMind machine won this game 4-1. So that is one of the greatest achievements nearby. And after that, what these guys did was these Google AI researchers. So they built another system called AlphaGo Zero. So that is the second version, or the version 2 of the AlphaGo in the DeepMind. And what it did was, so there's for the AlphaGo, there's no competition in human. So what it's trying to do is they compete each other with the AlphaGo version 1 and AlphaGo version 2. So AlphaGo version 2 begins in day 0 with nothing knowing about this board game called Go. So it starts from a blank sheet, and it get trained over and over using the AlphaGo version 1. And within 21 days, it managed to beat the AlphaGo version 1. So you can see how fast it is, how fast it learned and beat its teacher as well. Then again, it's machine to machine. And this is one usage. You can see all these birds, all these pictures are not natural. These are generated. These are computer generated images. You can see that what they did in here was they trained a neural network system with lot of birds, so with millions of birds in it, and then it just giving some description. The bird is short and stubby with yellow on its body. So these are the three example images that it's been generated automatically. So you can see the capability of these machines. And this is another example. If you guys have played Dota before, you know how complex it is. So this one is this competition was against the system called an AI system called Open, 5-time Dota champion. So OpenAI is another project of Elon Musk in his company. So what they did was then again openly challenged the 5 times Dota champion, and the machine beats the champion, the human champion. So this one considered as another achievement because earlier the DeepMind managed to beat the back then Go champion, but it's just a board game. So this one is a 3D game, which has far more movements, and it's much more complex than a board game. So this is another recent great achievement of machine learning. So that concludes this lecture to introduction to machine learning. So I hope that you got some grasp or some basic idea about what is machine learning and what is the AI is. So if you have any questions, you can reach back to me, and all my links are in the first slide. So that's it, and thank you for listening to this.